Alright, in this video it's time to put everything together and take our state-based enemy and give that enemy the ability to also seek a health power-up. At this point we need to establish what happens when the enemy collides with the player, because up until now we have a seek player behavior where the enemy is trying to chase the player to do something, but at the moment nothing happens when he finally catches the player. What we're going to do in this video is put together a scenario where when the enemy collides with the player, we will assume that we have done some massive amount of damage to the enemy so that the enemy has changed his mind and decided to seek a health power-up. We will also conveniently spawn a health power-up for him to find. So to get started, we're actually going to begin with the health power-up itself. We need to make some adjustments to the health class so that it can be activated or deactivated. That way it can appear in the level and it can disappear when it is picked up. So we'll jump into health. We'll jump into the health class itself, and we will create a public field. This will be a public Boolean field called active. Now we will adjust the draw method for the health actor so that it only draws when active is set to true. So we'll jump in here below our constructor, and we will add an override for draw. We're specifically overriding this so that we can conditionally call the base implementation of draw, since really it's in base where we actually draw the actor's own texture and do all of the rotational calculations. If we do override the method and then fail to call base.draw, then our actor will simply disappear. So this is the effect we're looking for with the active and deactive state. So we'll do a check and we'll say if this.active, then we will go ahead and call base.draw. If active is false, we will not call the base implementation and our health actor will disappear. Alright, now let's go back to the game scene and let's create a health actor. Let's scroll all the way back up to build scene and let's instantiate health and store it in the health field. So health will be equal to a new instance of health. Now let's also position it in the bottom left room of our demo map. So we'll set our health's position to be equal to a new vector2 where we will give the values 250 in x and 450 in y. Now at the moment, if we build and run, we won't see a health actor yet since the default value of our active field is going to be false. So once again, if we build, we see that the health should be in this area somewhere, but we don't see anything. So just to verify the positioning of our health actor, let's briefly set health's active property to true. Now if we build and run, we can see that the actor is positioned. The reason I wanted to check this was to make sure that health resided close enough to a path node to make sure that the enemy can reach it. Since the enemy is really going to be going to a goal node rather than to a specific actor, we do need to make sure that colliding with this node will actually cause him to collide with the health power-up. You'll also see that we now need to put together our behavior for what happens when the enemy reaches the player, since here he's just sitting there circling the player actor. So at this point, we need to hide our health back out, since until he collides with the player, he does not yet need health, so we will leave health deactivated until we hit the player. Now we'll move down to the update method, and we will add in a check for the enemy colliding with the player. Now what's interesting about this check is we will put it together as part of an else if check with our original sight radius collision, but we're going to perform the enemy to player collision before the sight radius collision. The reason we'll do this is since the enemy's radius resides within the sight radius, we want to make sure that the sight radius doesn't override the player-enemy collision. So we'll begin an if statement to check for a collision with the player. So we'll say if vector2.distance between the player and the enemy. So since we're checking the same objects, I'm going to grab both of these references of player.position and enemy.position and paste them into our new distance check. And we'll say that if this distance is less than player.radius plus enemy.radius, then we will consider the distance close enough to have been a collision. You'll also notice that this differs from the previous check where we were using the enemy's sight radius. Alright, let's brace this if statement in, and let's adjust our original if statement to be an else if clause. So here we can see that the priority for our collision check is first to see if we have the inner collision between the player and the enemy before we do a check to see if we're colliding with the enemy's sight radius. This way, the collision of player to enemy will override the sight radius check, which we need to do since, once again, if we're colliding with the player, then if the player's colliding with the enemy, then it's automatically colliding with the enemy's sight radius. Alright, now if we have collided with the player, it's time to change the enemy's state. So we will reach into enemy and call change state. We'll pass in a new state of enemy state dot seek health. Again, we're assuming that the player has done deadly damage to the enemy itself, and the enemy now requires health. Along with the state change, we will also activate the health power-up. So health.active will get set to true. Alright, now with our new state being set, we need to adjust the order that we change over from our sight state. It's easier to see this if we build and run. What's happening now is once the enemy finally reaches the player, let's get his attention by wandering into his sight radius. The moment he reaches us, we can see him change over to health, but he only changed very briefly, and then he wandered off the side of the map. Let me rerun the scenario with the enemy closer to the center of the screen. What will happen is he will briefly change to a state of seek health, but as soon as he leaves the collision with the player and goes back to the collision with the sight radius, you'll see that sight radius check takes over and changes his state back to seeking the player. So there he's seek player, he's chasing us around the map. Now if he reaches us, he'll briefly change over to seek health and then back to seek player. Because again, we leave the initial collision and go back to the sight collision. So what we need to do is we need to adjust our sight radius collision, our second if statement, and we need to only allow it to take effect if we are not seeking health. We'll let the health state override the seek player state. So we'll say if enemy.state does not equal enemy state.seek health, then we will go ahead and change our state to seek player. This means if we've collided with the player and have gained a state of seek health, then we will navigate to the health even if we have to cross over the player to do it. So now if we build and run, we can grab the enemy's attention, wait for him to collide with us, his state changes to seek health, and it stays seek health. You can see that this results with him wandering off the edge of the map and out of the game entirely, and this is because we need to now put together some decision-making code for the case of seek health. If we scroll up to the top of our class here, with our goal reached event, we need to add a check to goal reached to make a decision when we reach the end of a path to see if we are trying to seek health. We'll put in an else if statement that says if enemy state is equal to enemy state dot seek health, then we will begin navigation, but we will navigate to the health actor. So we will call navigate to actor, passing in the health reference. So now once we collide with the player, our state will get changed to seek health. When we get done navigating to the end of that path that brought us to the player, we'll notice that our state is seek health here in the goal reached event, and we will change our navigation to a new path leading us to the health power-up. So let's go ahead and jump into the game, grab the enemy's attention. As soon as he collides with us, you can see that a new path gets generated and the health power-up appears. So now I can navigate to the health power-up, but at this point, there is no code in place to let him grab that power-up, so he's going to sit at the closest node, continually trying to get access to the health power-up. So at this point, now we need to do one more collision check to allow the enemy to grab the health power-up. So once again, we'll scroll down to update. We'll create a new if statement below our original if-else statement. Once again, we will do a distance check, so I'm going to grab one of the existing distance checks as a baseline. We'll paste this in, so we have vector2.distance, but in this case, we're checking the distance between the enemy and the health rather than the player. So our distance between our health reference, so health.position and enemy.position, and we'll see if that distance is less than the overlap of our health and enemy actors. So if that's less than health.radius plus enemy.radius. If that case comes back true, then we need to pick up the health power-up. Now, in order to keep things in line with our state mechanism, we're only going to allow the enemy to pick up the health if he is in a state of seeking the health. So before we actually grab the health power-up, we'll say if enemy.state is equal to enemy_state.seek health, then we will go ahead and grab the health power-up. We'll do this by saying health.active equals false. So visually, the health power-up will disappear. Now, in addition to this, we need to change the enemy state, since at this point he has done what he was trying to do. He has reached the health power-up. We'll set his state back to a state of wandering. So once he gets done recharging his health, then he will continue to wander throughout the level. So we will say enemy.state gets set to, actually in this case we're changing the state, so that will be enemy.changeState. We'll change over to an enemy state of seek health. Or, excuse me, seek wander. Reading the seek health a little bit too much. So enemy state.wander, and that will take care of reaching the health power-up, grabbing the health power-up, and then resuming wandering operations. So let's test things out. Let's grab the enemy's attention, wait till he finds our current location. As soon as he collides with us, his state changes to seek health. He calculates a new path leading him to the health power-up, and you can see that as soon as he grabs that health power-up, the power-up disappears, the state changes back to wander, and he begins using the path node network to wander around the level. At this point, since he's back in the wandering state, we can grab his attention by running into a sight radius. He starts seeking the player once again, and if he is allowed to catch the player, then his state changes to seek health. The health power-up spawns. He grabs the health power-up, and at that point, he would have gone back to wandering, but we were too close to his location. But I'll let him finish off one iteration here. So back to seek health, grabs the health power-up, goes back to wandering, and the scenario begins again from the beginning. So you can see now we have an ongoing scenario of a wandering enemy that can notice the player and begin chasing the player. Once he collides with the player, he then changes his attention, finds a health power-up, and the scenario begins over. So with this now, we have employed everything we put together in the path node network to create a real-world game example where we have a player, an enemy, and things for the enemy to do. Now, in order to do one last test, let's hide out our path node network so that we can see what things would look like without the debug information. So let's very briefly jump into the node class, and let's scroll up to the very top of the node class and add a field. We're going to add a field that will let us turn our node network on and off. So this will be a public Boolean field called debug paths, and we will initialize this to false. So we'll say that we start off with our paths hidden. And let's now jump down to our draw method and employ this new field to decide whether or not we're going to draw. We'll say if not debug paths, then we will simply return without drawing anything. And you'll notice that we're placing the return before the call to base.draw. So if we turn debug paths off, we won't even draw the dots for the path nodes themselves. So now if we build and run, we can see that we are drawing no path information whatsoever, no nodes, and no connecting lines or debug info. So at this point, we can simply focus on what our enemy is doing and how he's navigating around the level. So currently he's wandering. Let's go grab his attention by sneaking up behind him. You can see that his state changes to seek player, and now he'll follow us all around the level wherever we go. So let's go hide in this corner for a minute. And he navigates around the level to catch us. Before he does, let's use the fact that we can run through walls and jump down to the bottom left. Now you see the enemy has to follow the rules of the node network, so he navigates to us using all of the pathways in the level itself. he actually has to follow the various hallways and passageways throughout the level. So this gives a much more believable effect, where we can see the enemy is properly using the level's own terrain. Now, of course, if he reaches us, then we see the health power-up spawn. His state changes to Seek Health, and he must now follow a path to the health power-up, after which the simulation will resume. But once again, he had to use all of the hallways to find his way over to the health power-up. Alright, so with this, now we have a simple flag that we can turn on and off, so we can always bring our nodes back if we wish to see what they're doing. But with them off, we have our final result for our game demo. So with all this in place, that's going to bring the game demo to a close. So again, we've got our game demo fully functional. That's also going to bring this video series over path node navigation to a close. Throughout this series, we have gone through a set of lessons that have allowed us to create the tools necessary to build path networks. We've taken a look at employing the A-star pathfinding algorithm to allow an AI player to use this path network in order to find his way around a level. After this, we took a look at integrating the pathfinding code with the behavior system created in this behavior demo. And finally, we took a look at saving out and loading nodes so that they could be used, or rather reused, in actual games. As we can see here, we've put together a game employing just such a path node network. So with all of this put together, that is going to bring this video and this series to a close.